Okay, so now let's talk about a particular type of robot which you guys will be working with in the activities and lessons, and that is called the differential drive robot. So the differential drive robot is arguably the most, the simplest type of robot out there. It operates on two wheels. Sometimes you have a third wheel. In this picture, it's not visible, but sometimes you have a third wheel, but power is usually not given to the third wheel. Power is usually given to these two wheels. So your Roomba, your vacuum cleaning robot, is an example of research labs and warehouse applications like Amazon Robotics. Yeah, so this is the simplest form of type of robot, and in this lesson, the activity of this lesson will basically ensure that you can move your robot using some basic kinematics. So without getting into the nitty-gritty of the mathematics of kinematics, what you essentially need to know is to control a differential drive robot kinematically. All you have to do is manipulate your wheel velocities, and you can observe different behaviors. For example, if you set both your wheel velocities as the same, your robot will end up moving straight. And if you set your wheel velocities as same in magnitude but opposite in direction, your robot will end up rotating in place. So it's a pretty straightforward robot to control. Okay, so this is another assignment that I would want you guys to do. This is a little bit wet to see what kinematics is all about. So suppose you have two links here, L1 and L2 of these lengths, and you're given the coordinates of the base, and you're also given the angles particular end effector. So you can try this out in Python, and you can see that this solution that you and that's essentially what kinematics is all about. But when you get into more complicated 3D, but it's essentially trigonometry nonetheless. Okay, with that, we've basically covered the theoretical aspects of this lesson. So I'll basically move on to the Vrep environment to show you what you need to do for this week's assignment in Vrep. So first you got to open up your software. So Vrep is now called Coppelia Sim, just to keep in mind. Okay, so once you've opened up your Vrep environment, it looks sort of like this. You have a basic floor layout, and that's basically it. So there are two parts to this assignment. One is manipulating your Vrep scene, and one is writing Python code to manipulate this Vrep scene. So let's first talk about the Vrep aspect. So what you have to do is go to robots and go to mobile robots, and click on Pioneer P3DX. So this is the same robot that I showed you in a couple of slides back. So this is a differential drive robot. As you can see, it has two wheels here. It actually has a third wheel, but yeah, like I said, power isn't given to that third wheel, so it's just there for like orientational purposes. Okay, so once you've got this robot, what you need to do is you need to open up a communication channel between this Vrep environment and your Python script. Now, there's just one line that you need to run, and what you have to do is you have to go to this resizable floor, and you can see this script icon right here. So double click that, and this is basically the command that you have to run. So the command is sim-ext remote API start, and the port, this is a port number 19,999. What this means is that this opens up a communication channel on this specific port number. So the Python script that you write should also have this exact same port, otherwise things will not work out. So once we have that ready, you can basically close this. And now we get to the second thing that you have to do to set up your Vrep environment, and that is you have to disable robot comes with. So all robots in Vrep,
Hey, kind of lost you there.
have they have an inbuilt script. You can see it right here. So this okay, sorry. So it's when I talked about the script here.
You said all inbuilt robots.
Oh, okay, got it. Yeah. So in Vrep, whenever you import a robot from this list right here, all of them come with a script in. What that means is they all do some predefined task. So the Pioneer P3DX robot, if you open this script icon right here, you can see that it has this script right here, which basically does a simple navigation task. And if you want to write your own Python script, you have to disable this script. Otherwise, what will happen is, if you click start, it'll start moving. And you don't want that to happen. You want to move it with your own script. So to disable that, what you have to do is you have to go to Tools, Scripts, highlight this Pioneer robot, and click on Disabled. And now if we hit run, it no longer moves. Okay, so that's basically it as far as arranging the Vrep environment. And now we can talk about the Python code. Okay. So this is all the code that you need to basically move your robot. It's not too complicated, but I'll explain line by line. So the Python module for Vrep, or Capella Sim as it's now called, is called invoke any Python commands of Vrep. You have to first import it using this particular command, import sim. Now import sys is basically if something goes wrong in your communication channel, you want to exit the channel, and that's what this thing is about. You don't have to worry about that as far as this assignment is concerned. But yeah, those are the only two libraries that you need to import. Once you've imported them, you first need to just as a precautionary measure close all existing connections. So if you're working with IoT devices or something, which is essentially what we're doing here, we're communicating between two pieces of software. You first have to close all your connections before establishing something anew. So that's what this line does. Once you've done that, you have to start a new communication channel. So if you recall, I invoked this particular command into that Vrep scene, which basically opened up a communication channel on this particular port. Now to establish or to finish that communication channel, you have to run this particular command. So sim dot, so that means that we're calling a function from the sim library, and sim x start. So that basically opens up, or basically establishes the communication channel. So this is your local host. This is that means that you're communicating with your own computer. And this is your same port that was there on Vrep. And these are just some boilerplate stuff. You can directly copy this line without worrying about what all of this means. And client ID is the value that this command returns. So if it returns a value of -1, it basically means that the connection is properly established. And if not, it'll basically close it. That's what this does. So if the communication has been properly executed, you will get into this loop. So now you have your Python script talking to your Vrep environment. So now what we need to do is we need to start defining variables for the Pioneer robot, and these are called handles. So this is the first thing that you need to do once your communication has been established. This is the command for it. It's called simx get object handle. So you can basically see it right here. Yeah. So this is the website for all the Python related functions in Vrep. I've attached a link to this in the PPT for your reference. But yeah, so this is the command that we have to invoke to get the object handle or to define the variables of the thing that we want to control. So these are the arguments it takes. Client ID, which is basically that -1 value, or the object name. That is the thing that we want to get the handle for. So for example, if we want to get the motor, we will invoke this particular command. Note that this the name that you give here should be the exact name that is present here. The left motor, right motor. So you can see that that's how the name is. And if you don't give the right name, it'll throw an error. And then you have your operation mode. So they've recommended an operation mode. So you should basically use that. If you want to see what they are all about, you can have a look in this link here. And yeah, that's what I've done here. So you have to define a left motor handle and your right motor handle. Now, once you've done that, you can now do stuff with your left motor and right motor. Namely, you can sort of make it move, make it rotate. And the command to do that is simx set joint target variable. Copy that. Okay. So the arguments for this is client ID, which is that -1 value. Your joint handle, which in this case will be this particular variable. For controlling the left motor, and your target velocity, which I just gave a velocity of 1, and your operation mode. They've given a default recommended operating mode, which is this or this. So you can just copy either one of them. And with that, you can now have your robot move its right wheel. Let's see that in action. Yep, and that's basically it. So you can see that it's not rotating in place as I described right here. So that's kind of because we're just moving one wheel. If you move both wheels, it'll rotate in place. And if you move both wheels with the same velocity, it'll move in a straight line. So that's sort of up to you. That's your assignment. You have to basically make it move straight, make it move back, make it rotate in place. Yeah. Okay, so that's basically it for this week's lesson. Next week we'll be talking about giving eyes and ears to the robot. So the robot's eyes and ears are basically your sensors. These are devices which enable the robot to perceive the outside world, and you'll be basically incorporating sensors also into your VREP environment, so that you can then do use both these modules to do more complicated stuff like controlling a robot to move in a line or whatever. And here are some links uh, that will give more insight to what kinematics is all about. And this is your Python function list of VREP commands. And yeah, that's basically it.
Cool. Thank you, Sharat.